So, good evening, everybody. We'll be looking at educational statistics. So, primarily, we are here for the calculatory aspect of it, the definitions, like what is statistics, types of statistics. You can already look them up. We have primarily two types, descriptive and the inferential statistics. Statistics, collection of data, set of data, and the rest. So, you can only look out those definitions of statistics and its types. So we are moving straight to the next question. What is the meaning of the following? What does the following symbol represent? Look at the question B part. So what do the following symbols represent? The first one is summation. This symbol here represents summation. This stands for summation, meaning sum. Then F stands for frequency. I'm looking at question B now, Roman figure 1. That symbol means summation, meaning you are adding all the items involved. So summation F. So what it represents is sum of frequencies. That is what it represents, sum of frequencies or total frequency. Summation F is sum of frequencies or total frequencies. That is what it means. So if you have a note, you can write it down. Summation F means sum of frequencies or total frequencies. That's what that sum means. The Roman figure 2 is chi-square. We call it chi-square. It's not x square. That is x, but when it comes to statistics, it's called chi-square. Chi, C-H-I, then square. That is what it's called, chi-square. It's used to test for hypotheses. That's what it's used to test for hypotheses, particularly if you want to do research. Use chi-square and other methods to state the relationship between two variables. So that symbol is called chi-square. Then the number 3 is called sigma. That symbol represents sigma. It's called sigma. Number 3 is called sigma. Sigma. That's what it's called. It's called sigma. We represent standard deviation. It represents standard deviation. That is what it's called. It's called standard deviation. But the name is called sigma. That's the name. But the symbol itself represents standard deviation. The Roman figure 4, like I said, if you have a note, you can just jot them down in case you meet them on Saturday. So Roman figure 4, that one is called square root. Normal square root, we all know, is called the square root. That symbol there is called the square root. Symbol, Roman figure 4, this symbol is known as square, it's called square root. That's what it's called. Then the last one is mean. This symbol means a mean, or they call it population mean for populations, or you call it population mean. That is what it's called. You can call it mean or population mean. That is what is that's what that symbol is called. So that's what those symbols represent. Each of them will be 5 marks. Each of them will be 1 mark, total 5 marks. That's 5 marks you are saying there. Then question 1C. Question 1C says the frequency distribution for the number of minutes per week spent watching TV by 290 ODL students as contained in the table below. Now, the total number of people who watch TV per week, per minute in a week is 290. How did they arrive at the 290? That is the total frequency, total number of people, which represent what we said earlier for this, for summation F. It represents the total number of people that watch, which is total frequency. So if you add 14 plus 46, this is 14, 46, 58, 76, 69, 62, and 6, it's going to give you this 290. So if you have a calculator, you can try it out. 46 plus, let's try it out. 46 plus 14 plus 58 plus 76 plus 68 plus 6, you are going to have this 290 here, which is our total frequency, or the total number of people involved. That is our total frequency, or total number of people. Why this 30 to 39, we call it class intervals. The 30 to 39, 40 to 49, 50 to 59, down to 90 to 99, we refer to them as class intervals. Meaning, people that watch between 30 minutes to 39 minutes are 14 persons. Those that watch from 40 minutes to 49 minutes are 46 persons. 50 to 59 minutes are 58 people. Then to 90 to 99 minutes are 6 people. Those are people that watch the television throughout the week. So if you must have some people, you discover that we will have 290 at the end of the day. So the class interval is made up of two numbers. The class interval is made up of two numbers. Let's illustrate it. Let's use one as an example. Let's use 30 to 39 as an example now. 30 to 39. The 30 is called lower class limits. It's called lower class limits. While the 39 is called the upper class limit. That is what it's called, upper class limits. So then, if you go back, 40 to 49, the 40 is not the lower class, the 49 is the upper class. 50 is the upper class, sorry, 50 is the lower class, 59 is the upper class, 60 lower class, 69 upper class. Just like that, then 90 lower class, 99 the upper class. Now, if you look at question Roman figure 1, the question says, find the upper class limits of the fifth class. The upper class limit of the fifth class. What is the fifth class? You count. This is the first class, the second class, the third class, the fourth class, and the fifth class. So they are asking of the fifth class. Then, not only that, they are asking of the upper class limits. So from what we have done now, from this illustration, the first one is the lower class, the second one is the upper class. So by mere looking at the question, you know that the upper class limit of the fifth class, the answer is simply 79. You don't have to do anything. The answer is simply 79 because 70 is the lower class, 79 is the upper class. So the answer is simply 79. That is it. No, you don't have to solve anything in this case. You don't have to. Then, if you go to Roman figure 2, you go to Roman figure 2, the question says the class mark of the third class. Now, we have mentioned two things now, class interval. The class interval and the range from year to year, from this one to this one, is called class interval. Under the class interval, you have lower class limits and upper class limits. So I hope that is clear. The lower class is the first one, the upper class is the second one. So what about class mark? How do we get class mark? Class mark, you can use these two to obtain class mark. Just as every other one, you can use anyone could obtain class mark. Let's use the first one, 30 to 39. The 30 to 39, remember we said it's called class interval. That is what it's called, class interval. It's called class interval. Then under it, this is the lower class. I will say this is lower class. Why this is the upper class. So you can only see lower class and upper class from a class interval. Now, the question they're asking us now, they're asking for class mark. Class mark. The class mark is represented with the symbol X. That's what the class mark is represented as. You represent with the symbol X. How did you get your class mark? The class mark is the sum, is the upper class plus the lower class. Upper class plus the lower class divided by 2. That's how you calculate your class mark. The upper class plus the lower class divided by 2. So if you go back to the question now, they are asking of the class mark of the third class. This is the first class. The first one is the first class. This is the second class. This is the third class. So they are asking of the class mark of the third class. So we are dealing with what? 50 to 59. So if I go by the formula, now let's apply this formula now to determine the class mark. So we're going to have 59, which is the upper class, plus 50, which is the lower class, divided by 2. This is X. It's called X, like we said. The upper class plus the lower class divided by 2. If you sum up, 50 plus 59 will give us 109. You divide it by 2. So what is now our class mark now of the third class? All you need to do is to divide by 2. You're going to have 54.5. This is now the class mark of the third class. So I believe it's understood. If you want to find your class mark, you add upper class plus lower class, you divide it by 2. It depends on the class mark they are asking of. Like they're asking for the third class. So I will start counting from the beginning to get the third. The third is 50 to 59. Divided by 2, that will give us 54.5. That will give us 54.5. So let's go to Roman figure 3. Roman figure 3. So we should determine the class boundary. The class boundary of the sixth. Who is now the sixth? This is the fourth. This is the fifth. And this is the sixth. So they are asking of 80 to 89 now. Because they said it's of the sixth class. So we are dealing with 80 to 89. So how do we get our class boundary? The class boundary is also gotten from the class interval. Remember we said the ones on top are the class intervals. So you can get your class mark from it. You can get your upper class from it. You can get your lower class from it. You can get your class boundary from it. So how do we get our class boundary now? This one involves a simple principle. Let's use anyone for example. I'll come back to answer our question. Let's use 40 to 49 as a case study to determine our class boundary. So we have 40 to 49. So what you do in this case, to get the class boundary, we're looking for class boundary. Class boundary. Class boundary. So what you do, you subtract 0.5 from this to give the lower class boundary, UCB, SCB. Then you should add 0.5 to this. This is minus 0.5. Why this is plus 0.5 to give you the upper class boundary, which is UCB, upper class boundary. So if I add 0.5 to this, that will give me 49.5. If I subtract 0.5, it will give me 39.5. So the first one is now your lower class boundary, while the other one is now your upper class boundary. You subtract 0.5 from the lower class, you add 0.5 to the upper class. So if you go back to the question now, let's go back to the question. We are dealing with the sixth class, which is the 80 to 89. So what are they asking of? The class boundary of the six. So they didn't tell us whether it's the lower class boundary or the upper class boundary. So we are dealing with the two. We are going to deal with the two. So we'll be having 80 to 89. 80 to 89. So like I said, you subtract 0.5 from the lower class and add 0.5 to the upper class. So if I subtract 0.5, I'm going to have 79.5. If I add 0.5, it will give me 89.5. So this is the class boundary of the sixth class. Yeah, that's the class boundary of the sixth class. I believe it's understood. Let's go back to the question. Question Roman figure 5. It says, find the percentage of students whose weekly viewing does not exceed 60 minutes. Does not exceed 60 minutes. So, how many students view from 30 minutes to 60 minutes? Does not exceed 60 minutes. So, this one is within, 30 to 39 is within 60 minutes. 40 to 49 is within 60 minutes. 50 to 59 is within 60 minutes. But 60 to 69 has gone beyond 60 minutes. So how do we get the percentage of those now who view within 60 minutes? So how many people first? Number of people view within 15 minutes is 14 plus 46 plus 58. These are the people who view within 60 minutes. So if you add them up, what are we going to have? 14 plus 46 plus 58. That will give us 118 persons. 118 people view within 60 minutes. So how do you get the percentage now? Remember, we know the total number of students who participated in the exercise, 290 people. So the percentage will be percentage within 60 minutes. Within 60 minutes will be the number of those that view within 60 minutes, number within 60 minutes, number within 60 minutes over the total, It's times 100 over 1. So it's the action of percentage times 100 over 1. That's 100 over 1. So number of those within 60 minutes over the total number of people who participated, that's 100 over 1. So that will give us 118 over 290 times 100 over 1. So what are we have? We're going to have 11800. That means if I should multiply 118 by 100, you have to give us 11800 divided by 290. All you need to do now is to press your calculator. 11800 divided 290. That will give us 40.7% of people view within 60 minutes. 40.7% of persons view within 60 minutes. Let's go back to the question. That is question Roman figure 5. Let's check for Roman figure 6, if there is any. Let's check for question Roman figure 6. So if you have any question, you can ask. If you have any question, you can ask. So in the absence of none, we're going to continue. So let's see what question we have next. Let's see the question we have next. Try to shift this question forward. Okay. Okay, let's see the next question. Roman figure 5. They're asking of us relative frequency. They're asking of us of relative frequency. Relative frequency, just as percentage, has a formula too. Relative frequency has a formula. So in this case, we are just dealing with frequency, relative frequency. So of the sixth class, who is the sixth class? We've done that before. The sixth class is this. Relative frequency of the sixth class. So what is the frequency of the sixth class? Is 62. So the frequency of the sixth class is 62, and the total frequency is 290. So what will be the relative frequency now? Our ROF, which is called relative frequency, is the frequency they ask of over total or sum of frequency times 100 over 1. The frequency they require, and let me put 6, frequency of the 6 now. To be more specific, the frequency of the 6th class over the total frequency times 100 over 1. So let's check the frequency of the 6th class. Who is that? Is 62. And our total frequency is 290. So I'm going to have relative frequency now of the 6th is now 62 over 290 times 100 over 1. So if I multiply, I'm going to have 6200 divided by 290. So my ROF, which stands for relative frequency, will give us what? So if I divide from my end, 6200 divided by 290, that will give us 21.4%. That is now the relative frequency, 21.4%. That is how to calculate the frequency they ask for over the total times 100 over 1. That's how you determine relative frequency. So if I go back to the question, and think that is the whole of question 1, and we made question 1 mandatory. It's a compulsory question. So with that, I think you've crashed it. Like I said, you can look up definition of statistics. It's all about the collection and analyzing and computing data. The types of statistics, descriptive and inferential. That's question A. Question B, we stated the meaning. And question C, we also describe, we have calculated all that is required here. So with that, we can advance to question 2. Advance to question 2. Like I said, if you have any question, you may ask. Can advance to question 2. So question 2, there are no questions. Let's continue. Question 2 says 540 different animals were kept in the farm of National Open University of Nigeria, Kaduna, as shown in the table below. So 540 different. So how did they come about the 540? How did they come about that 540? If you sum 15, 30, 90, 45, 150, 108, 102 is going to give you this 540. If you sum all of them together, you're going to have 540. So that's how they came about the 540. So the next question says we should calculate the percentage composition of each category of each animal. The percentage composition of each category of each animal. Percentage is the animal over the total times 100 over 1. And the total is 540, as we just seen. So the percentage of cow will be number of cow over the total times 100 over 1. It's number of cow over the total times 100 over 1. So that's how you get your percentage. Okay, so let's try it out. If you try it out, but I believe, you can hear me, I believe this question is wrong. It's not ought to be percentage. It's supposed to be sector. Not ought to be percentage. It's supposed to be sector. Because you are going to use it to answer this question 2. This Roman figure 2. You will use it to answer Roman figure 2. But we are going to do both of them, but I believe the question is wrong. since it requires you to use it to draw a pie chart, that means it's a wrong question. But we're going to do it in both. We're going to calculate the percentage and also calculate the sector, so that you know in case anyone comes, you know the right thing to do. So let's start with the percentage of cow. So for cow, will be the number of cow over total animals. Total animals times 100%. So this is how you calculate percentage. Number of cows needed over the total animals times 100. So for cow, how many cows do we have? We have 15. So that would be 15, 15 over 540, which is total number of animals times 100 over 1, which is 1500 divided by 540. 1500 divided by 540. So let me multiply from here. 1500 divided by 540. That will give us a 2.78%. That will give us 2.78%. The percentage of cow now will give us 2.78. I hope that is understood. Give us 2.78. Okay, 2.78%. Then let's go to the next one. Who is the next animal? Is dog. How many dogs do we have? 30. So for dog, we're going to have dog, which is number of dog, which is 30 over 540 times 100 over 1, which is 30 over 540. So 3,000 divided by 540, that will give us 5.56%. That will give us 5.56%. That is for the dog. So the next one is the goat, which is 90 goats. We're going to have for goats, I'm going to have number of goats is 90 over 540 times 100 over 1, which is 9,000 over 540. So if you multiply, and I want to divide now, 9,000 divided by 540 from this end, that will give us 16.67%. That is for goats. If you go back, you have pig, 45. You have the same process, 45 over 540 times 100. Rabbit, 150 over 540 times 100. Turkey, 108 over 540 times 100. And sheep, 102 over 540 times 100. So that's how you get the percentage of those. It's actually, they are asking for percentage, which I believe is not ought to be percentage. The question is supposed to be the sector composition of each animal. Because we are going to use it. Say you scale the pie chart representation of this animal. That is why I believe it's not sector, because of the Roman figure 2. I'm supposed to use Roman figure 1 to answer Roman figure 2. So how do we do sector? A sector is formed, it's a circle divided into different parts. That is a sector. When you divide a single circle into, this is a circle now. When we share circle into different parts, it's what we call a sector. This is a pie chart. This is a pie chart. A sector make up a pie chart. So when you divide circle into different sections, the circle itself is called the pie chart, while the division are called the sector. So from our secondary school, we are told that sum of angle at a point, all of them meet here, this place. Sum of angle at a point is 360. Meaning if you sum all the sectors together, all the sector angles together, you are going to have 360. So how does that connect to this question? To calculate or draw a pie chart, you must calculate the sector. for each animal. So let's do that now. So how do I calculate the sector for cow? How do you calculate the sector for cow? For cow, I will know that total angle is 360. So for cow, we're going to have, for cow, we're going to have 15 over the total, which is 540, times 360 degrees. Because we just agree, sum of angle in this circle is 360, which is this, is 360. That's why we are using 360. So if I multiply and divide, we're going to have 15 times 360. That will give us 400 divided by 540. That will give us 10 degrees. So that's why I believe it's a sector, not percentage. That question is wrong. So this is how you do sector, 15 over 540 times 360. That will give us 10%. So if I go to the next one is dog. How do you calculate the sector for dog? The same procedure for dog. We are going to have number of dogs is 30 over total animals 540 times the sector, angle in the sector is 360. So if I multiply 30 times 360, that will give us 10,800 divided by 540. If I divide this, that will give us 20 degrees. So this is what the question says, not the other way around. So this is how you will continue each of them to the last one. This is how you continue each of them to the last one, which is sheep. So let's do for the last one, the sheep. So for sheep, I'm going to have number of sheep is 102 over the total number of animals is 540 times the angle sector is 360. So I'm going to have 102 times 360. That will give us 36720 divided by 540. If I divide, what will I have? Divide 540 from here, I'm going to have 68 degrees. So this is what the question requires. This is how you calculate for sector. But the first one is how you calculate for percentage. So instead of using percentage is 100, that's why we are using 100. For a sector in a circle, total angle is 360, that's why we are using 360 in this case. So how do we translate this to draw a pie chart, which is Roman figure 2? Question Roman figure 2. How do we translate it to draw a pie chart? Like I said, a pie chart is a circle divided into different sectors. So first of all, you're supposed to use a pair of compass at a very large radius to draw a thick circle. While you take note of the center. Take note of the center where you put the pin to draw the pie chart. So you can look it up. You can look how pie chart is constructed. I don't have a drawing instrument here, so I may not be able to give you clearly how it's constructed. So next thing, you have to draw a straight line from there to hit one side of the circle. Then you use a protractor. That thing I look like this in a mathematical set. It's calibrated. Here is 0, here is 180. There's somewhere here is 90. You have to use that. Somewhere here is 10, 20 to get to 90, 100, 110 to get to 180. So you place this point. You place this point now, this 0 to 180 along this line. Along this line. Then you measure the first angle. What is the first angle there? Let's go back to it. What is the first angle calculated? Is 10. Then you measure 10 degrees as the first angle. So from here to here now, I'll measure 10. I will roll it. Then you now put your t-square in this manner. T-square will not be in this manner now. You can change it. It will not be this manner. Then from here you measure 20. You roll it. Just like that, you get to the last one, which is 68 degrees. So the question actually is for sector, not for percentage. Because on either way, you know how to do the two now, for percentage and for a sector. So that's how to do for sector. I believe it's clear. If you have any question, you may ask. Then question B is define each of the following terms. Mode Most is the number with the highest frequency. The simple definition. Most is the number with the highest frequency. Question 2, you say you should define range. So all these definitions, you can definitely look them up. I think they are in the material. Question 2 says you should define range. Range is defined as the difference. The word difference means minus. As the difference between the highest number and the lowest number. That's how you define a range. As a difference between the highest number and the lowest number. Then the next question you should define quartile. The word quartile is gotten from quarter. Quarter is over 4. So quartiles are values that divide an order set of data into 4 equal parts. The word quarter means 4. You say quartiles are values that divide an order or set of numbers or data into 4 equal parts. Then percentile is taken from the word percentile is taken from the word percentage. It's taken from the word percentage. So this time around, we are dividing a set of data or numbers by what? By 100. That's what I mean by percentile. It's taken from the word percentage. And each of them is 1 marks. That is the 4 marks. The question 3 says to differentiate between spammer rank order and poem biserial correlation. Like all these things are in the textbook. I'll look up all those definitions.
Please, yes. the percentile, please, I didn't get it.
Okay, all right. Let me come again. But you got the rest?
Yes, yes.
Okay, so the percentile, I didn't hear you.
I can hear you.
Okay. So the percentile is dividing a set of data or numbers into 100 equal parts. Dividing a set of data or number into 100 equal parts. That is the percentile.
Thank you. I've got it. Thank you.
Okay, okay. Then the next one is say give 2 characteristics of a standard score. Like I said, you can look them up. All these things are there. There are many definitions. Mention 4 methods by which open and distance learning TM score can be standardized. Open and 4 methods by which open and distance learning can be standardized.
Sir, hello, sir.
Yes.
Please, can you throw that's number 3A, please? That's spammer rank order. Just give us a little the differentiation of the spammer rank.
Between spammer rank order.
Yes, sir.
Okay. The spammer rank, spammer rank order is used to determine the relationship between 2 variables. Let me say X and Y. Is used to differentiate. Is used to differentiate 2 variables, such as X and Y, used to test or determine the relationship between 2 variables. So if I say, for instance now, boys perform better than girls, or let me say girls perform better than boys in mathematics. So that is an hypothesis. Are you getting it? That is, a hypothesis is a declarative statement. So the spammer rank correlation order is to state the relationship between the 2. Why is it so? Is it a true statement or a false statement? So it's used to test for hypothesis. That's what the spammer rank is used for. Why the other one, they call it point biserial correlation. So correlation also is to test relationship between two variables. That's what correlation is used for. It's also the relationship between two variables, but this time is to measure or test the relationship between continuous variable and discontinuous variable. That is what this point term correlation is used for, to test the relationship between continuous variable and discontinuous variable. That's what it's used for. Okay? Is it clear?
Yes, it's clear now. It's clear.
Okay.
Thank you.
So the other one, say give two characteristics of a standard score. Anybody knows that? Characteristics of a standard score as used in our TMA test, what's it called? Test tutor mark assessment, right? I mean,
Yeah,
score.
tutor mark assessment.
Yes. So what are the four methods we use four methods by which you can standardize our scores? Anybody knows that? So there are actually different methods you can use. It's to moderate. It's to moderate scores. When you write now, you get maybe 30 or 25, and they will record it. It's to moderate scores. That's one method. Then it's also equip the teacher or the lecturer as the students are faring. And maybe if they are performing poor, it may need to reduce the nature of the questions, or maybe it means that maybe they are not doing something right, or maybe they are not using the right teaching aid or instructional aid to teach. So generally, it's for formative evaluation to test whether you actually understand what you have read. So these are two methods. You can look up the other two methods of doing so. Then the Roman got two questions. Say give two characteristics of a standard score. Number one, it allows comparison. Why this score is better than the other. Two is to express derivative units of scores. So these are some of the characteristics. Or like all these things, like said, they are in your materials. You can definitely look them up. They are there. So with that, I think we are done with question 3A. So let's advance to question 3B. Let's see what they have for us there. The question 3B says calculate the mean of the following set of scores in educational statistics method for 100 students, using assume mean method. Using assume mean method. So, like I said, if you add 5, 18, 42, 27, and 8 together, it will give you this 100 you have here, which represents your summation F, or total frequency. You can try it out. 5 plus 18 plus 42 plus 27 plus 8 will give you 100. That is how you know whether the number you actually gave you there is right, is correct or not. So for in examination condition, make sure you add up to be sure it is 100. Then you calculate mean using an assumed mean. So it has a formula. One thing about statistics is that you will know the formula. The formula will help you to track what you are doing. You can know the formula will give you a sense of direction of what you are doing. So let's first of all take the formula of an assumed mean. Okay? So mean itself is called X bar, which is A plus summation FD over summation F, where the A is we call the A is the assumed, our A is the assumed, our A is the assumed mean. While D is called deviation. The D is called deviation. Then F, as we know before, is frequency. So now that I've written the formula as this, so with this formula will now guide me to solve the question. That means I need to get summation f. I need to get deviation, then multiply the frequency with the deviation. Then I also need to get my assumed mean. I think so. A formula that will guide you to the solution. So if you don't know the formula, it will be difficult for you to do anything about the question. It will be very, very difficult for you to do anything about it at all if you don't know the formula involved in a particular question. So you can see all the calculations we've done, so we'll be doing since they require formulas. All of them require formulas. So if you don't know the formula, like I said, it will be difficult for you to do anything at all about it. So we are asked to find the mean now using an assumed mean. So how do we get the assumed mean? You can get the assumed mean from the table they gave to you. You can get the assumed mean from 61, 64, 67, 70, 70, and 73. So from these numbers, you can get the assumed mean. So anybody have an idea how you can get the assumed mean from this table? And one suggestion. Anybody know how you can get the assumed mean?
Assuming, what do you mean, sir?
I can hear you.
Okay, I assuming should be the number. Is not the number free total summation of the number all over summation of the numbers now all over the number.
No, that method is okay. 61 plus 64 plus 67 plus 70 plus 73. That will give us 335 divided by 5. That will give me 67. So you are very correct. The assumed mean is our 67. So this is our A. That's the assumed mean now. It's our A. You get it? So in place of this assumed mean now, we've gotten the value. Our A now is 67. That's the A. So the next question is, how do we get all this, the remaining parts, to calculate the mean? How do we get the remaining parts? So first of all, we need frequency, we need deviation, and we need total frequency. So let's draw a table for it. That means we need to draw a table for it, the score and frequency. And we need a table for score and frequency. So I will draw this table now. The score is your X, then the F is your frequency. So what is the first value there? What is the first score there? Is 61, frequency is 5. We have 61, frequency is 5. We have next, we have 64, frequency is 8. Next, we have 67, frequency is 42, if I'm not mistaken. Then we have 70, frequency is 27. We have 70, frequency is 27. Then we have 73, right? Let me check. We have 73, frequency is 8. 73, frequency is 8. So then next, to get our deviation. The deviation is A minus your score, which is the assumed mean minus the score. Don't forget our assuming A is what? Is 67. So I'm now having 67 minus, which is score there? 61. 67 minus 61, that will give us 6. Then 67 minus 64, that will give us 3. 67 minus 67, that will give us 0. 67 minus 70, that will give us minus 3. Then 67 minus 73, that will give us minus 6. Okay. Then the next one, you need to get summation. No, you need to get summation, or let me just say FD. Let me not put summation yet. Let's just say the next one is FD, meaning your frequency is multiplying the deviation. So if the first frequency there is 5, what's the deviation? 6. So 5 times 6 will give me 10. The next one is 8 and 3. That will give us 24. The next one is 42 times 0. That will give us 0. Then 27 times minus 3. That will give us minus 81. Then 8 times minus 6. That will give us minus 48. So if you go back to the formula we wrote earlier, we have gotten all the information we needed. So now we can calculate the mean. We've gotten all the information we needed. We can calculate the mean. So first of all, I'll find summation FD. I'll find my summation F. So what is summation FD? That means I'm adding everything here to give me the sum of summation FD. So my summation FD will be 30 plus 24 plus 0 plus minus 81 plus minus 48. That will give us minus 75. Then summation F, total frequency, is 100. Or you can still add everything here. You can still add everything here together, will give you 100. So now that I've got this, we cannot calculate the mean now. We cannot calculate the mean. So my X bar now, which is the mean, is now my assumed mean 67 plus my summation FD minus 75 divided by 100. So X bar will give us 67 plus minus 75 divided by 100. You write the value there, minus 0.75. So if you add it to 67, what are we having? That will give us 66.25. This is not the mean, 66.25. I hope that is clear also. I hope that's clear. So if you have any questions, you may ask. So that is that for question 3B. Then question 4A down is this one. This one is under advanced statistics. The Hanover, Maneuver, Ancover, and Maneuver. So those ones, they are advanced statistics. So the Hanover, you can see write it down, stands for the Hanover. Hanover. It stands for analysis of variation. Hanover stands for analysis of variation. Stands for analysis of variance. Analysis of variance, not variation. Analysis of variance. That's what the Hanover stands for. Then we also have the Maneuver. We also have Maneuver. Let me write it on the board. Maneuver. So this one stands for multivariance. Multivariance analysis of multivariance is just the multivariant analysis of variance. Analysis of variance. That is what the MANOVA stands for. Let's go to the next one and see. The next one is ANCOVA. Next one is ANCOVA. I don't know if you've written that. Next one is ANCOVA. Let me go to the next page. ANCOVA. All these ones, they are under advanced statistics. Here is analysis. Analysis of covariance. Analysis of covariance. That is what the ANCOVA stands for. Then the other one, MANCOVA. MANCOVA. The MANCOVA stands for multivariance, variant, multivariant analysis of covariance, analysis of covariance. So those are their meaning. They fall under advanced statistics. I don't know if this is the material. I don't know, but you can check it out to be sure if they are there or not. And I don't know for sure. Then the next one, say which of the following inferential statistic measure t-test? So you're asking us now, which is the ANOVA or the ANCOVA or multiple regression? Which of the following measure t-test? T-test, like I said, is used to test for hypothesis, just like the chi-square. So the ANOVA is used to test for inferential statistics. We have t-test, we have the ANOVA, we have the ANCOVA, we have the multi-regression. No, sorry, it's not the ANOVA. We use t-test to test for inferential statistics. Like I said, the t-test is for test for hypothesis. It's used to test for the inferential statistics. Then the second question, say if T calculated is this and T table is this,
Yes, sir.
what is
Excuse me, sir. The II, you said the II is what? Is it?
The II, okay, is t-test. We use t-test for that. T-test.
Okay.
Which is the first one here? That is the first
Okay.
one, your t-test. Yeah, t-test.
Yeah. Okay, thank you.
Yes. Then the second, figure 3, if T calculated, that is if I don't calculate your T value, the 0.175 is calculated T value. Why the T table value is showing 2 points? Okay. Okay, they're asking of, sorry. Yeah, they're asking of each of them. You say, what does each of the following test for? What does each of the following test? So yeah, we are going to deal with this test. We are going to deal with ANOVA, going to deal with ANCOVA, and we're going to deal with ANOVA and ANCOVA and the multiple regression. So the first one, t-test. So let's do with the t-test, right? T-test. The t-test is used to determine whether there's a significant difference. Like I told you that time, it's to test for hypothesis. It's used to determine whether there's a significant difference between two groups. Like boys perform better in physics than girls. So the test will determine whether it is true statement or a false statement. And hypothesis is just a declarative statement. So it's the test that will determine whether that statement is true or false. So to determine whether there's a significant difference between two groups, that is for the t-test. Between two groups or more, that's for the t-test. Then the ANOVA, you can write them. Number 2 is the ANOVA. The ANOVA is used to test. Let me just write it. It's used to test. It's used to test whether they are, just like the t-test, whether they are significant difference, whether they are significant difference, whether there is significant difference among the means of 3 or more groups, among the means of 3 or more groups. So that's or more groups. That is what the ANOVA is used for. Then number 3, we have the ANCOVA. Number 3, we have the ANCOVA. I hope you have written it. I want to go through it because of time. I'm not going to go through it because of time. Okay. Yeah. Then the next one is ANCOVA. So like all these, like I said, they are used to test. Used to compare group mean. Is used to compare group mean while controlling the effects, while controlling the effects, of another variable. That is what the ANCOVA is used for. And lastly, the multiple regression. This one is used to test the value of dependent variable using 2 or more independent variable. It's used to test the value of dependent variable using 2 or more independent variable. The multiple regression. Let me go to the other page.
Sir, please. Repeat it. Repeat the. He said it's used to test.
Is used to test or predict the value of a dependent variable using 2 or more independent variable. Is used to test or predict the value of a dependent variable using 2 or more independent variable. That is what the multiple regression is used for. That's what it's used for. Okay?
Okay, thank you.
Yes. So let's check the next question and see. Let's check the next question and see what they have there. I can't find this question. Give me a minute, let me search for it. Okay. So the Roman figure 3, we have t-test. Like I said, the t-test is for hypothesis to test whether a statement is true or false. So he said, and the t-test have a formula. He said after you use the formula, they got 0.175 as a value. They also have a t-test table value. It's like a 4-figure table. It's like, in fact, it's present in four-figure table. Look, you go back on the four-figure table, you're going to see T table. So the T table shows that the value is 2.042. So the question is, what decision will you take on the non-hypothesis at 0.05 level of significance? So the non-hypothesis, it means that somebody make a statement. There's no difference in performance between boys and girls in mathematics. That is a non-hypothesis. There's no difference in performance between boys and girls in mathematics. We also have alternative hypothesis. Alternative, which says there's a significant difference between boys and girls when it comes to mathematics. So, but now they are using the non-hypothesis. That means there's no difference at all when it comes to performance on boys and girls in mathematics. So the conclusion we can draw from here, with this, we can calculated and T table with the level of significance of 0.05. What decision can you make from there? Now, look at the decision rule. Let me state the decision rule for you in case you say anything like that. Decision. So how do you make decision based on the values that you have? Please take this one very seriously. Decision rule. One, you reject the hypothesis. Reject means you reject the statement or the hypothesis if, which is HO, you reject the non-hypothesis. The HO stands for the non-hypothesis, while HI stands for alternative hypothesis. You reject the non-hypothesis if T you calculated greater than T table. Then you accept the non-hypothesis. You accept the non-hypothesis if T calculated is less than T table. If T calculated is less than T table, you accept it. So now let me tell you a secret. Now, if you want to know the two, you will get confused. So just know one. The one you know is the opposite of the other one. So just know one of it. Just know whether you are just know the one of rejection or not the one of acceptance. But don't try to know the two. Anyone you know is the opposite of the other. Okay. So you can know the one of accept if you want to. You can know the one of reject. If you know the one of reject, so you should be able to know the one of accept. Accept will be what? Less than T table. And reject is greater. Accept is less. Now let's check the values we have. If the T table is less than or greater than the T value. So what's the T table now? Is 0. Our T table value, our T calculator, is 0.175. Then our T table is 2.042. So you can see that T table is less than T value. So, sorry, the T calculated is less than the T table. So what decision are we making? Are we accepting the hypothesis or we are rejecting the hypothesis? We are accepting it because it's T calculated is less. This one is 0.175. This one is 2.046. So since this one is less than this, you accept the non-hypothesis. Is that correct? That means there's no significant difference between the two. Performance of boys and girls when it comes to mathematics. So I believe that is understood. So next, let's find the next question.
Not significant
said,
of what?
I didn't hear you.
It's not significant of what?
There's no significant difference. And not hypothesis means there's no significant difference between two groups of people when it comes to performance tests or performance evaluation. There's no significant difference between two sets of people. Let me say boys and girls in chemistry. Performance, there's no significant difference. Meaning boys and girls do equally. They do equally. No one performs better than the other. So we accept the non-hypothesis that there's no significant difference between the performance of two groups. Then question B.
Sir, please, sorry, sir.
Okay.
What year question is this, sir? I'm
I don't
struggling
really
to
know. I
get the
just
year
submitted it
written
from.
on.
I didn't really check. Let me go through it.
Oh,
I didn't really check.
219. 219.
219.
213.
Okay, it's 213. Okay. I not really check it. Okay. Okay. So what's the question B? You say, what is hypothesis? Like I said, it's a declarative statement to determine whether a statement is true or false. That's hypothesis. It's a declarative statement to state or to determine the relationship between two variables. It's a declarative statement to determine the relationship between two variables to test for statistical tests. That's the definition. When we have two types of hypothesis, we have the non-hypothesis, which is the non-HULA, and we have the alternative hypothesis. Alternative hypothesis. So these things are common in research. They are very common in your research. All these words, the non, this N, sorry.
Please, the hypothesis is what?
It's a declarative statement. Okay?
Yes.
To predict the relationship between two variables. To predict the relationship between two variables. That is hypothesis. It's a declarative statement to predict the relationship between two variables. That is hypothesis. And they have two types. We have the non-hypothesis and alternative hypothesis. The non and alternative hypothesis. Those are the two types of hypothesis, non and alternative. Okay. Then let's go to the next question. It said, enumerate 3 types of sampling techniques. And all these things are present in your research. If you have done research, there are types of sampling techniques there. We have a simple random sampling, stratified sampling, and systematic sampling. So types of sampling, we have number 1, we have simple random sampling. Number 2, we have stratified sampling. They are present in research. All these things are there. Number 3, we have systematic sampling. So these are the types of sampling techniques that we have. These are the type of sampling techniques that we have to sample data. We use any of these methods. Let's go back to the last question, which is probability. Let me raise it up so everybody can see it well. I also have another question B there, B1 and B2. So let's look at question A first. It says a box contains 3 white balls and 2 black balls. While the balls are drawn and not replaced. So this is the probability without replacement. So maybe they have 30 balls in the bag. You took one out, you didn't put it back. That's what they mean. That's without replacement. We remove one ball, you didn't put it back. That means the number of balls in the bag will reduce by 1. Anytime you take from it, you didn't drop it, reduce by 1. That's called the probability without replacement. The question is, what is the probability that a red ball the first ball drawn is black. The first ball drawn is black. So let's see how we do this. Now, I'll take into account numbers of white balls. Numbers of white balls. Numbers of white is 3 balls. Then numbers of black is 2 balls. So let's assume this is the bag. We have white balls, 3 of it, and you have 2 black balls. Let me use yellow to represent the black balls, because I don't have black marker in my system. So these are the number of balls in the bag. So let's look at what is total number of balls now? So total number of balls is called the sample space. We're now having 3 plus 2, which is 5 balls. Which is 5 balls. So with this now, can I answer the question? Question mark on 1. So what's the probability that the first ball drawn is black? So probability of black, which is B, probability of B, so black, is the number of black balls over sample space. That means we take one ball. How many black balls do we have? Is 2 over what? 5. That's the probability of black ball. Now you take black ball, which is over
the normal probability, but no say I'm for calculation.
Whether?
Are you using your ethics?
You say what? Okay. Then we've got 2. Second ball drawn is also black. Second ball drawn is also. We took the first ball, which is a black ball. We didn't take it back. Now you're not removing. You're not taking on that black ball. So if I take black ball, I didn't take it back. That means I have 4 balls left. So I have 4 balls left. So remember, got 2 prob B2, which is second black ball, which now will be 2 divided by 4. Because by taking the black ball, the number of balls in the back I've replaced, I've reduced. I didn't put it back. So the number of balls now we don't have 5 but 4. So 2 here 1, 2 here 2. Our answer is now 1 over 2. Then Roman figure 3. Now we got 3. Probably that both balls are black. Both balls are black. That means probability. The first one is black. The second one is black. So probability of the first ball is black is 2 over 5 times 1 over 4. I take the first ball, which is black, 2 over 5. The number of black balls are reduced to 1, and the total number of balls are reduced to 4. So probability of the second one will be 1 over 4. So 2 here 1, 2 here 2. Our answer is now 1 over 10. That is now the solution to the question. That is the solution to the question. Question B, Roman figure 1 and 2. So differentiate between subjective and objective probabilities. Explain 5 features of randomization in sampling process.
Sir, please, I didn't get that probability solving, please.
The probability?
Yes, sir.
Okay. So this is the first question. Are you done with it?
The down is called, I cannot really see it.
I didn't hear you.
The down part of it, that place you wrote probability.
Okay. This is X. N bracket X. N, let me rewrite it. This This is over n bracket x, which stands for sample space or total number of balls. It stands for sample space or total numbers of balls.
Sir, can you help me with the explanation again, please?
Okay. Now, let's go back to the question.
So,
It says a box contains 3 white and 2 black balls. Why the balls drawn are not replaced? That means in a bag, let's say you have 5 balls in a bag, you took one out, you didn't put it back. That's what they mean by non-replaced. You remove one, you didn't put it back. You remove another one, you didn't put it back. So if I remove one from the bag, the total number of balls in the bag will reduce to 4 because they are 5. If I take another one out, total number of balls will reduce to 3. Just like that. That's what you mean by without replacements. If you take it back, you don't put it back. You take it from the bag, you don't keep it back. So, first of all, you need to know. First of all, you need to know the total number of balls in the bag. We have 3 white balls and we have 2 black balls. So let's see. So I'm now right. Numbers of white balls is 3. Then the second one, numbers of black balls is 2. So what's that the total number of balls, which is called the X? Total number, this was called sample space.
Okay.
And it's called sample space. That is the X, which is the total number of balls. So we are now having three white plus 2 black. That will give us 5 balls. Now, question one says, what is the probability that the first ball drawn and the first ball you took from the bag is black? So how many black do we have? It's 2 blacks. So you are going to have 2 black balls divided by total number, which is 5. That's why we got 2 over 5.
Okay.
And the second one is, yes. Do you want to ask a question?
No, sir. I got this one.
Okay. So remember, we got 2. Say the second ball you draw now is black. Second ball you draw. Don't forget, you have taken away 1 black ball. You are not taking away another black ball. So that will give us what? Number of black ball is 2 over 4. Because by taking away 1 black ball, total number of ball have reduced to 4. So if I take another black ball, it becomes 2 over 4, which is 1 over 2. Then remember, we got 3. You say probability of picking, the 2 balls are black. That's why I use B1 and B2. The first ball is black, second ball is black. So we have a total of 2 black balls. So the first one will be 2 over 5. So if you have to, that means the number of black balls have reduced to 1, which is the 1. And total number of balls are reduced to 4, which is the 4. So I'll cancel out 2 here 1, 2 here 2. 2 times 5 is 10. So I'm left with 1 over 10 as the solution. 1 over 10 as the solution. So that is for that, as far as the question is concerned. Then remember, we got 3. He said, should differentiate between subjective and objective probability. So it's differentiate between subjective and objective probability. Any solution to that? Any solution to subjective and objective probability?
And the only person I never see somebody for.
Okay. So there are ways of solving probability, subjective and objective. So for the subjective, the probability is based on, it's not based on facts. That is subjective. It's not based on fact or data or mathematical calculation. It's just a random probability. While the other one is based on facts, while the subjective is based on facts or individual values. So you can also check it up. Based on subjective is based on personal belief, judgment, experience, or opinion. Means when you say something subjective, it's your own personal opinion. When it's subjective, like when I say now, if we are in the night and I said we are in the morning, that is a subjective statement. But what is objective reality? What is objective truth? We are in the night. So subjective is based on personal belief, preferences, and opinion. While objective is based on facts. Objective is based on facts. So that's the difference between both of them. So the last one, you can check it out. I check the last one out. So that will be, check the other question out. Thank you for your presence. If you have any question, like tomorrow we'll still be here after your exam. I believe I was told you are writing this exam on Saturday. So I will still be here tomorrow to discuss.
Yes,
if you have any questions,
thank you so much.
About any area of
Thank you
interest,
so much, sir.
apart from the one we have done.
What time are we meeting tomorrow?
Whether? I didn't hear you.
I said what time are we meeting here tomorrow? What time are we meeting tomorrow, sir?
A similar time, maybe around 7 o'clock. We start early so you can do your personal reading. We start early, spend an hour or two so you can do your personal reading. Start by 7.
All right, sir. Thank you.
Yes.
Thank you so much.
Thank you for joining.
Thank you.
And we have a YouTube channel. You can support us by subscribing. We call it STEM Up Africa. So you can just subscribe to it by use to support us.
Yes,
They don't charge anything. You don't collect your data, you don't collect your money. It's absolutely free.
Yes, I have subscribed already. Thank you so much.
STEM Up Africa. It's absolutely free. No money is charged. No data is collected. So, like I said, if you have any question, any specific question you want to know that concerns you, just send it to the WhatsApp group. We'll treat it one by one tomorrow. Just send it there. If you are treating it, everybody's benefiting from it. So it's a win-win. But just select a specific area you want to know.
Okay, sir.
All right. With that, I will take my leave. See you tomorrow.
Thank you so much. Have a good night's rest. Thank you.